resurrecting my robot Neo, praising the Arduino Mega, and looking to the Terminator for salvation. Your Minister of Intelligence, preaching to the choir. It's been 1 year. Lucky episode 13 of the Robotcast. Baby. Carl Linder, your Minister of Intelligence. To my great shock, I can proudly announce that the Robotcast has been online for a whole year. Thanks to everyone for your watching and for your support and your feedback, especially regarding the last episode. See, when pressed, I can edit. I hope you all got a flavor for how much fun it was to spend a weekend hacking out a robot fabricator with about 40 of your friends. It really got me in the mood to get back to building robots. But with so much going on, it's hard to get started from scratch. And then I remembered. I've been doing the Robotcast for a year here. Did anybody wonder why I have an old Shop Boss vacuum cleaner sitting right here? Well, turns out this is Neo, an old robot project that I built for a class years ago. I found the vacuum in a second-hand store and I really liked the frame, so I gutted it and used it as the shell for my robot. Neo was built, yes, even before the first Matrix came out, and he's been kind of sitting in a corner, neglected, underpowered, and waiting. When I built him, he was designed to be a simple, expandable sensor test bed. His only real job was to roll around chasing light sources and not run into stuff. And though I've built more advanced systems since, I miss my little buddy. I have the technology. I can make him better. Let's take a quick look at his internals, and please, I just want to remind you, I was in school when I built them. I had like duct tape, a power drill, and a hand hacksaw, so just prepare to be frightened. Neo has a simple suite of sensors on board. I was just getting started when I built him. So, in front you see he's got 3 analog light sensors. He's got ring along the base are infrared detectors, which detect a signal pulsed at 40 kilohertz, I believe. You can see them scattered along the base here, and there's another one. Here's the little holster where the infrared LEDs fit, and they pulse the signal out to reflect off of walls and nearby surfaces. Here in the center, probably the most prominent sensor. This is the old school Polaroid transducer here. You see it's got the golden hue. Now they make a new model now, which is a pair of tin cans, but I like the gold ones better, man. Back in the days when I first got started with robotics, you weren't really doing sonars unless you had the Polaroid on there. So, okay, I'm sorry. Suddenly I'm the Andy Rooney of robotics. Did you ever notice they don't make transducers as nice as they used? I'm sorry. So here you see Neo with his Shop Boss housing removed, the dominant drive wheels. You see the card cage in the front, a microcontroller on the top, and as we spin it around, oh yes, the most critical part of my machine, I build no robots without a heart. So, okay, there you go, a little superstition of mine. In the back, of course, the primary power, a pair of lead-acid batteries, 5 amp hours each, 12 volts from, state-of-the-art Radio Shack. Yes, you can get a pair of those. Keeps the robot running for a while. Deep inside, you see the H&R vintage DC gear motors are locked in there. Each combined, they can move about 100 pounds, so no loss of power with Neo here. Really gets the job done. In the front, the controller boards. Across the top, this is the H-bridge, 3 H-bridges for left, right, and a head motor that I haven't put in. Some infrared detectors there for each of the ring of sensors. Those are the pulsars, the oscillator board for the infrared LEDs. This is, light control board, light brightness detection. Here you see an actual Dusty, carved out of the archive, 6811 microcontroller board from New Micros. I don't use that anymore. And okay, the system as a whole, sort of the exploded view. There's the case and all of the different parts. If you were to lay it out, this is what goes into Neo. So, despite all the ugliness, most of the boards seem to work, and this is a rugged little frame. What was needed was a more modern microcontroller that's easier to work with. I had my eye on the Arduino family of controllers for a while. They're capable, easy to use, and you just can't beat the supportive community that's grown up around it. But for controlling robots, there just wasn't enough I/O. Until the Arduino Mega. This little board has 54 digital I/O pins, 14 of which can be used for pulse width modulation, which means you can pulse a pin at a set frequency without burdening your program. This is perfect for motor control, servos, light dimmers. But this was my first time working with this board. So what's it like powering up and programming the Arduino Mega? Alright, to get started, connect your computer of choice to the Arduino Mega via the USB cable. You need your breadboard with your LEDs and buffer circuits. Here, a ribbon cable to connect the signals together. And here you see my Soviet-era DeVry power supply, which converts AC to DC current using, of course, a transformer. I've found Decepticons to be particularly good regulators. I think the DeVry pumps out about 9-12 volts, goes into the 7805 voltage regulator. 5 volts powers the 7404 buffer to drive the LEDs. Our signal port is connected to the input of the 7404s with my ribbon cable here. And again, make sure you connect the grounds so that the two boards can talk together. Then you power it up and get started. Getting the software you need to begin working with the Arduino Mega is really straightforward. You just, Google on Arduino downloads, go to their main site, and pick the download program for your platform. Here I'm using the Mac. When you install the Arduino environment, the screen looks like this. You start with a sketchbook where you load your program. Here it's called CarlBlink Mega. The syntax is very straightforward. It's a lot like Java. You compile it for the specific board that you have. So I choose Arduino Mega, of course. Once you compile it, then it's ready to be uploaded. But you have to choose the proper communications port. Here we're using the USB as serial, so you select it there. Then you go about uploading your application, your program, your software to the I/O board. If you look at the board, you'll see the little LEDs flashing indicating that the software is loading in there. It'll tell you the size of the program and that it is done. It's uploading successfully. Then the board's ready. This is just a demonstration. I encourage you to actually read the documentation if you want to play around with it, but I promise you it's very simple. So with the code uploaded to the Arduino Mega, you'll see our I/O pins are connected to the inputs of the 7404, and bam, the hello world microcontroller world, flashing LEDs, is working. We'll use what we've learned here to, instead of flashing LEDs on and off, actually control the motors aboard Neo on the next episode.